Now let's discuss working with complex queries. As the data stored for business applications becomes more and more complex, so do the queries needed to extract that data. And as developers, we learn that debugging those queries presents its own set of challenges. In this section, we'll talk about two simple but effective techniques for making the complexity more manageable. We'll discover how to safely debug queries and prevent the accidental modification, or even worse, deletion of data. And that's even important in a test environment. And then we'll learn how to break up large tasks into smaller, more manageable, and when appropriate, reusable pieces of code. Often when working with complicated queries, it's nice to work in a controlled environment. This is especially true when we're performing DML operations, inserts, updates, or deletes. And sometimes testing queries that modify data is difficult. If the outcome of that query isn't exactly what you expected, restoring that data may be time-consuming. SQL Server can process transactions using one of several supported modes. Auto-commit is the mode where SQL considers each statement a transaction. Explicit transactions start when we issue a begin transaction, but they don't complete until we explicitly issue a commit or rollback. And then there's implicit. Transactions start when a prior transaction completes by receiving an explicit commit or rollback. And finally, there's batch scoped. Only occurs with multiple active result sets, and SQL will automatically roll back the batch scope transactions if they're not explicitly committed or rolled back when the batch completes. We want to take a look at implicit transactions. Here you can see the syntax. Set implicit transactions on or off. Very straightforward. The key here is when in implicit transaction mode and not already in a transaction, any of the following T-SQL statements will cause SQL Server to begin a transaction. And you can see here it's quite a variety, including our normal DML operations. And once an implicit transaction is started, issuing an explicit commit or rollback will actually complete the transaction. Implicit transaction mode will remain in effect until you explicitly turn it off. So we're going to take advantage of this. Because transactions will roll back unless explicitly committed, you as a developer can test queries and their results without making the changes permanent. But there's always a catch, and here's the warning. Forgetting to turn off implicit transaction mode will cause all changes made to roll back when the connection closes. Now, if you're testing, probably not a big deal, but you want to be careful when you're talking about production code that you don't inadvertently leave that setting on. So let's go to SQL Server Management Studio and see an example of using implicit transactions. Okay, in this example we're going to take a look at how to use implicit transactions. You can see here that we are explicitly setting that mode. We're turning on implicit transactions, and what that is going to allow us to do is to perform some DML operations without actually committing the transactions. And this is great for testing. So we're going to start out with a very simple select statement. We are taking a look at the products that we have in our subcategory number 2 that have yet to be discontinued. Their discontinued date is null. And we're just going to produce that count so that we know how many there are. And the reason for that is we're going to follow that up immediately with an update. We're going to set that discontinued date to be the current date and time. And at this point, once that update is executed, under normal circumstances, that would be completely committed and we would have discontinued those products, so to speak. But because we're in implicit transactions mode, we can actually just say, hey, ignore it, didn't really care. and it will return back to where we were before we started. So you'll see here that we're going to go get the number of products that have yet to be discontinued. We are then going to select again after this update has occurred, and we should see that number change. We should find out how many have been discontinued. At this point, it should be everything because we said set the date. So we should see this count come back as 0. And as I said, under normal circumstances at this point, if we were trying to debug something or work through something, those rows may have indeed been permanently changed. But because we're in implicit transaction mode, we're going to be able to go ahead and throw those away and come right back and reselect, and we should see that those changes in fact did not stick, and we will have the number of rows satisfying our condition of not being discontinued match what we started with. And then we wrap everything up by turning that off just because we want to be good coders and make sure that we're not leaving that setting on. So let's see what we get when we run this. Remember, we're going to select, update, roll back that transaction, select again. And if we execute that, you can see here the original count where there were 43 products that were not discontinued. We did the update, which now said everything's discontinued. We rolled it back. There are now 43 without a discontinued date, which is what we expect, and we were able to debug that query a little bit easier than we would under normal circumstances. So take advantage of implicit transactions when you can. In this section, we're going to try to convey the idea that when working with very complex processes, it's often best to break that overall task into smaller, more manageable ones. Rather than writing that really big monolithic T-SQL query, we're going to produce several small procedures where each one performs a very well-defined piece of functionality. Again, we're going to consider each of these routines as a black box. Receives input, does some operations, sends us output. If you focus on this approach, it makes implementing complex tasks more straightforward. Some major benefits are working with smaller procedures makes them easier to debug. They're certainly easier to maintain. There are black boxes or Legos that allow us to reuse them over and over and over again. Deciding which T-SQL constructs to use to implement each portion of the larger task really does depend on its purpose. Because as you may know, T-SQL provides multiple ways to perform the same task. Some general guidelines to consider are, if there's a need to join the results of one subtask to another, you might want to use a user-defined table-valued function or a work table. If you happen to be within a single task and there's a need to refer to a result set multiple times, then consider common table expressions, a table variable, or a temporary table. And unless it's absolutely necessary, try to avoid performing heavy operations, such as sorting, especially within your subtasks. And whenever possible, try to design for reuse. Let's go over to SQL Server Management Studio and simplify a complex process. Here we're going to take a look at 4 quick examples. And these will demonstrate how we take a complex process and break it down into smaller tasks. We're also going to emphasize reusability. So the concept here is we want to generate a list of items that are in our inventory, and we also want to look at what promotions we had going on during that time for those items, if any. Now, we might be tempted to build a very big complex query to do all of that work, but we're going to take the opportunity to kind of consider how we might reuse some of that functionality. One of the things that kind of jumps out is, because we're talking about inventory, maybe there's a need for us to know what our inventory levels are based on our orders at any given point in time. So this is going to be our first kind of breaking down of that big task, we're going to create a function that will return to us our inventory levels based on the orders taken for a given time. So here we're going to create that function. For any given subcategory, we are going to send back the sales order level and inventory level for the individual products. And you can see here that the function is returning a table. We're also going to take advantage of the fact that we can use a CTE to do some work. So we've defined a CTE here that is going to do the work of selecting the product and the number of items in inventory. And then we will use that CTE down here in the select statement that feeds that table that we're going to return. And so here you can see that we join against that CTE right here, and that CTE is holding our inventory levels. We're going to take a look at our sales order information, join against the inventory levels, and return back that table that says, okay, for this given time period, here's what's been ordered, and here's what our inventory levels are. So let's go ahead and build that piece. We'll go and execute the whole thing. And everything was successful. So now we have the first part of our large task taken care of, which was to handle the inventory piece. Now the other part of the puzzle was we wanted to figure out for any given point in time, were there any promotions going on? So what we're going to do here is again create a function that handles that. It's structured very much the same. We have a subcategory, start and end date. Go ahead and return a table of products that have promotions going on and give us the percentage and if there's a minimum or maximum quantity needed to receive the promotion. And we'll do the same thing here. We'll insert into that table the result of selecting against our various tables, and the point of this is to return back that table of promotion information. So again, here we're taking this opportunity to build this as reusable functionality. This is going to be a function that we can call, so we're going to go ahead and execute that, and that worked out just fine. So let me dismiss this guy here and this guy so we can create some room. And over here we have the third part of our example, which is to create a stored procedure, another reusable piece of functionality that is going to use both of those functions to generate the results that we need. Again, this is all based on the subcategory that we're interested in and subdate range. So this now becomes rather straightforward. What we're doing is we're just going to return a set of rows that are joined, or actually I should really, to be correct, that the result set is resolved by looking at our product table and doing a join against the function that returns our inventory levels and the function that returns our promotion information. You can see here we're passing in the appropriate arguments, and when we execute this, we'll end up with a stored procedure, another piece of reusable functionality that we can take advantage of. So we now have a procedure that is reusable. The procedure itself is using reusable pieces of functionality. So that leaves us with one final piece to the puzzle, which is selecting that data out. So let me dismiss our stored procedure here. And we are left with producing the results to this very complex task. And all it ends up being is executing the stored procedure with the subcategory that we're interested in and the date range. And this makes producing those results a lot more straightforward. We're making a simple call inside of that reusable piece of functionality. It's going off and using those user-defined functions and those functions are returning the tables, and all that work is happening in those reusable pieces of functionality. So you can see here the results of looking at subcategory 1, and if we do it for subcategory 3, we would expect something similar. And we're getting back those inventory and promotion pieces of information, and now we also have the ability to get those pieces of information related to inventory or promotions independently. And the whole point of this is not only did we satisfy the business need of generating a list of inventory and promotion information, but now we have a bunch of reusable functionality that we can use for other tasks.